good. And, okay. So, good morning, everybody. Let me see. Okay, first of all, one slide of the presentation of Leonardo. Maybe not everybody knows about this company. Leonardo is a global leader in aerospace and defense. Leonardo does a lot of things, but mainly related to the defense and aerospace, as I said. Its main headquarters is in Italy, but we have a lot of subsidiary and four main what we call domestic countries, which are Italy, UK, US, and Poland. These are where we have production sites and employees. What we do, well, maybe Leonardo is most famous for its rotary wings helicopters. This probably Leonardo is leader in the world, also for not only for military aircraft, but we own the Augusta brand, which is a VIP brand for helicopter, quite success. So most of the VIP helicopters in the world are Augusta. But then we also are engaged in production airplanes, jet fighter, and drones and tanks, and we build not to ship, but the electronics for the ship and space, and last but not least, cyber. So said so, let's try to. This is my view about the silos. So so breaking the silos. What are the silos, first of all? No? So these are a few slides about what are the silos from the point of view of the technology, from the point of view also not only the technology but the organization and so on and so forth. But let's first start from the technology. So the silos for HPC to me are the full range of application today related to the uses of chip and in particular artificial intelligence. So we may say that AI is everywhere, so it is HPC. So now you cannot sell anything or write any piece of software that does not contain AI. This is the market. You listen to the radio and one advertisement over two for the common people have the AI in its narrative, and so is for HPC. Today, especially if you want to run a generative AI, you need to have a HPC component within the solution. And so let's see what the silos are. Top 500. So top 500 and big science. This is the first one. So it was for many years the only community that was speaking about HPC. So HPC was not known outside. It was something that you cannot even heard when you speak with IT people, or where IT was enterprise IT. So big database, big mainframes, and HPC was a very funny word. But the same cloud, you never heard about HPC when the cloud started. Cloud was big data, it was data lakes, it was mobility and storing of large amount of data. Telco, now in Europe, we had also, we found the so-called edge a few years ago with an initiative that was called IPCI, important project of European interest, something like that. And then they miss a little bit of HPC, because we wrote it, we were part, we insist, but HPC was not yet, because ChatGPT was not yet there. Okay, so ChatGPT was, so nobody was in, so edge was the edge of a telco. But now you go with a telco, this is a real telco machine, and they bought last year NVIDIA. They do not know what to do with that. They need to buy it because the market needs AI, and so someone tell them, look, if you want to run AI, you have to buy this kind of NVIDIA stuff. So HPC is in the telco, is in the cloud, is in the big science, but now we are speaking also having AI in space. So we need to have processing power and run AI application in space. So space guy, when I talk with them, because now I'm in Leonardo, and I will explain also later, I'm also in charge in designing and collaborating to design the HPC payload for future satellites. And when I speak with them, and I explain what HPC really is, they say, no, high power computing. No, high power, no. Yes, for you it's high power because 100 watt in a satellite is a lot of power. or 1,000, a kilowatt is a lot of power for them. But they say high performance computing, so power is a consequence. But then we have also we are speaking internally with guys designing UAV. So UAV need to be, for the future, need to be fully autonomous without being remote controlled. So they've been able to find their way, even without the support of GPS, because maybe GPS, as you have heard probably, you can hide the GPS signal or you can make it noisy, and so you lose your position by means of electromagnetic countermeasure. And so the UAV need to look at around him and using artificial intelligence find this way for his mission and coming back home. And this requires a lot of computational power. Robots, okay, these are real Leonardo robots. These are very heavy robots that is designed to rescue mission in the structural environment. It's easy to build a robot that is able, once again, to move in a well predefined pattern and system, but it's very difficult to teach a robot to move in a structured, not previously taught environment. So it's important to have high power computing or high performance computing in robots as well. But then today we are going down also from the edge, telco edge, also to deep edge. So with a mini server, this exaflop scale mini server, right? Or AI. Qualcomm CEO a few weeks ago announced that his goal is to have AI in mobile phone without, even without, let's say, a cloud connection. So the possibility for mobile phone to run their own AI locally, even without connection. And this will require HPC, and Qualcomm is designing an HPC chip and a GPU as well. And finally, the deep edge, where we have monitoring when you would like. This is also one of the cases we are studying in API. So when you have thousands of cameras and you want to apply AI in order to find something in the scene or in the situation that is dangerous, you need a lot of compute power to elaborate and cross-correlate all the. And when we start API, this was not so obvious the importance of this kind of application, but now everybody recognizes that this is a very important kind of application I don't know if it is good or bad, but it's there, so we have to face it in a way or another. Okay, but this was about technology or environment where we see as a company, but many are seeing the competencies, first of all, of HPC guys looking at this kind of devices. But we have other silos, especially in Europe. I mean, many working group in many different organizations around Europe. So we have HPC. This was the first one about HPC. But we have now also ChipJU. We are speaking and we are telling about HPC because they need also in edge devices. We ordered the design for the GPU in Europe require, or the GPU or the CPU also for the edge, required to have HPC competencies. No? But then we have ASD, which is Aerospace and Defense Association. We have a working group, and we are speaking of HPC. We are speaking what we have to do in order to have more HPC infrastructure, not those of probably of our, or, well, there will be the AI factory and then the gigafactory, where we can, let me say, have an infrastructural solution, or where we can go to reshape or to simply communicate the requirement aerospace and defense application, where we can, our requirement in terms of aerospace, in what infrastructure are taken into consideration when we design infrastructure. In our HPC system, the only requirement was about big science and top 500 a few years ago. Now, aerospace and defense need, for AI, need HPC. We have requirement, and which infrastructure is ready to take this requirement to be included in the design phase, both from the point of view of the chip, but also in the system, the final system to be deployed, so that we can have a fraction of the workload of the machine available for research and development in aerospace and defense. Then we have the European Alliance for Industrial Data, Edge and Cloud. This is where we have most of the telco, but we have again once aerospace and defense company, and again here there are working group discussing of AI, and then as a consequence of HPC. Then we have big data BDVA that we know very well, sort of they understand a few years ago already that they need also to share requirements with the ATP for HPC. There was, in the meantime, we also been part of Gaia X effort. At least we spend a lot of time on it. I don't know if it will. And then we have the European Defense Fund, where, once again, we are speaking of AI. There are a lot of projects about AI and HPC. So the message is, should we be able to have, instead of having, at least this is for my time, for rationalizing my time, should we have something of coordination, let me say. I don't know if it is HPC, but also European level, to have, instead of replicating many time discussion and a lot of working group where we maybe people start to discuss, they have no background, they start to discuss, we lose a lot of time in order to build up the background for them to understand what are the limits, what are the possibilities, and so I think it's dispersive, and probably we need some sort of the European level of for Europe to elect a sort of coordination board among the different initiatives where we are starting to speak about HPC. Then the last one, research and industry. So this two machines where I've been involved in the deployment. And one is Leonardo, and so we are Leonardo. This is Leonardo from Chile, and this is the Da Vinci from from the Leonardo company. So it's a funny joke if you want. But once again, the Leonardo da Vinci are two different. It's different. It's once again a silos and the industry have different requirements with respect to academia. So we have problem with disaster recovery. We have problem with regulation. We have problem with IT department. With you can imagine security. We are also designing and building classified computers. So, and today, well, classified computers are once again for HPC mostly. So are those requirements taken into consideration from the community as a large, or we are just looking at the top 500 once again? So I think there is a lot of room down there to explore, to have a larger community being involved, or larger customer community to be make aware of what we do in API, in Euro HPC, not thinking just at the top 500. And yeah, most of the time is also problem of languages. So talking the same languages in the industry and in academia, because and the top priority are different. The top priority in my company is we have three department of security. So my first is this chip featuring encryption? Who is doing the encryption? Where is the storage? Where the performance is the last thing for the cybersecurity guy. Then you have the logistics. We have to redesign a data center. How we do the data center, and you have traditional IT department in the industry and a legacy also for building management. So people that are doing building management, they do not know about water cooling for a server. No. Are you crazy? No, we need water cooling. We have to redesign the full building, and that's the sort of problem we are facing in industry. Okay, so let's see that these are the problem we are facing, where we can find the convergence. At least this is my view, and where I'm finding myself the convergence inside the company with the different department. The convergence is toward AI. So today, actually, we may still be fond of big science, big simulation. I myself, I was for many years developer of one of the code at scale on hundreds of millions of threads, scalability. For most of the people that require HPC today, these are meaningless. They do not care. The only thing they care in the market, and when you do discussion with customers, but also with providers. In Leonardo, we collaborate with a lot of consultancy company or other company. I have my phone every day. I got a phone call of someone that would like to sell me some new AI, whatever. Every day. It's incredible. And so, but yeah, for the economy and for the market today, the top technology that you have. You need to be able to provide and exploit is AI. Then everything's now is AI. So even a loop now is a Fortran loop becomes AI. So everything becomes AI. But this is what people and the board of directors would like to hear from you. So are we doing AI? Are we selling AI? that's what your board of directors asks. Then to provide this artificial intelligence solution, so you need big data. You need big data because without data you cannot use the AI of someone else, okay? Not yours. If you have your own data, you have to build for your satellite images repository, you have to build your foundation model, you have to build, so you need big data. Big data stack, I mean, so software, big data software stack. There are thousands. I have so every data scientist have its own preferable stack. No? And so we have to install in IT infra or HPC infrastructure thousands of stacks. Then the problem comes on with the compatibility. So most of these stacks are, well, someone require one version of that, someone else require a version of this other one, no Python 3.11, no Python 13, no this library, I need CUDA, no I don't need CUDA, I need this. So there is a problem of matching requirement of all these stacks. So HPC bare metal is not efficiency, or you either partition your machine, otherwise it's impossible to have just one single operating system dealing, so that you spread across the machine, dealing with which is the traditional HPCs as we know layout, to cope with all the craziness and the craziest things that the data scientists need to train the model, to test the model, to develop the model, and they drive the business. So you have to comply with their requirements. You cannot say no, get off of my data center which is clean. No, you should provide their service. And so the solution is to have a sort of cloud stack or Kubernetes. So whatever is a decoupling between the hardware and the big data stack. Because otherwise you find yourself not able to cope with the diversity of the many workload. So you consider in Leonardo we have 5 divisions, so from aeronautics, from space, from my own, another land, electronics. Everybody has its own 100 data scientists, and they have their own, and we have to accommodate all this. So cloud stack is the solution we found in order to accommodate the requirement of the data scientists, so that they can install and manage the data. Then we have HPC and quantum computer. We are working on that, but we know it's a long way to go. The quantum computer to be usable. I will show you what we are doing. But the hardware, the high performance computer, and then here is where we can have our own competencies that we, let's say, build up over the year together with the others. At the end of the pyramid, we have the skill and competence that tend to be domain specific. So we have engineers, biohealthcare, so these are different requirements, different skill, but everybody would like to use AI. We have space, finance, defense, you may name it. Everybody would like to use AI, and so everybody will need sooner or later HPC competencies and infrastructure to allow. Otherwise, once again, in order to exploit AI, we will use someone else's hardware, which is spread on all type of devices. So NVIDIA, you can find NVIDIA hardware from the very high end. Also, the same core, you find it in the Jetson deep edge kind of device. So you have a full range. If you take NVIDIA, they cope with all community. They are speaking, they are very good. They are convincing us that they need NVIDIA device for doing AI. So you can find AI, you can find the NVIDIA devices in almost all domains, in a full scale, in a full range of solution, not just high-end HPC server. Okay, let's see how we internally to Leonardo part of this. So we had this idea. So what we did this spring, the last April. My unit was for the first 3 to 4 years was an internal unit, so providing service internal to the company. But then, thanks to the AI, we see our customer asking Leonardo to start to provide solution to exploit AI, to build AI solution for themselves. So Leonardo decided to launch this spring. We launched 2 things. One is space unit. Now is in discussion, is in the newspaper. We are in discussion with Thales and Airbus to try to build an European champions for the space business. And we launched this Leonardo Hypercomputing Continuum, which is the unit I'm leading, to provide what services to not only inside the company, but also to our customers. So internal to the company, this is just a few slides of what the growth. When I reached Leonardo almost 5 years ago, obviously nobody was using a high-performance computer, just, yes, server, workstation, and a few things. Now we have 2,000 registered users in the HPC, and the amount is 2,000 researchers. So we have the large majority of the users are engineers, and as I said, in order to be able to gather in the machine, in the infrastructure, all this amount of users, I had to cope with many different requirements, not just the very big simulation. So my goal was, okay, let's try to start to educate everybody inside the company to the HPC, try to cope with the requirement, and then let them grow. And actually we are triplicating the machine right now, and this is only for the internal purposes. Yeah, we have been we became a profit and loss unit and starting to work with the customer. So starting with the captive market, because Leonardo being a large aerospace and defense, we have a sort of captive market where we have to provide a solution for, and this is what we do in terms of units. So we provide a solution for, we do not build hardware, as you know, we build our solution for customer on the basis of someone else's hardware, so we do not produce ourselves hardware, but we are able to replicate what we did internally to the premise of the customer. So many of our customers came to visit us and said, I want the same, what it cost me to have the same for my defense division, and we say, well, we can provide it, we can let's design together the system. Let me talk with your user, so I can get the requirement from your user, what they need to do, what they want to do, and then we'll provide you a design of a machine, and we'll help you in RFI, RFQ, managing the procurement, managing the machine, and deploying the machine, and everything set. And the problem from them, and where we found a lot of, I think, success, is that most of the defense people that are trained in IT are trained in enterprise IT. So they are gathering internally requirement from the department to run artificial intelligence, and they simply do not know how to manage large artificial intelligence infrastructure. But then we can provide our system as a service for, once again, selected number of users. We are already hosting workload from, well, a lot from Leonardo. Leonardo is an internal customer, but also from the groups. So Leonardo is a group and has many companies, a subsidiary company, and the company can use the machine. We provide the service as long with selected customer that they need our expertise and they would like to run their workload. We have already quite large pipeline for satellite image processing running on the machine, and this is almost what HPC guys in the past was claiming not to be proper parallel computing, because it is high throughput computing. What the difference? The difference is in the software stack and in the sharing of the file system. The computation is done in a high throughput way. We are designing a solution. We are helping colleagues that build payloads for satellites to design a new payload for the future satellite, which will carry HPC and AI on board of a satellite. And also, we are designing a software stack. We have a military project found by Italian Ministry of Defense to design a space cloud, so a software that can allow satellite to share data between them. So this is otherwise, so cloud is where you can share, first of all, you can share data. Because the goal is to have all quasi real-time image processing and answer and communication that can be direct to the user. Because now today, user of satellite have to go through a ground station that talk to the satellite, so the data do a long path before reaching the final user. So, and the final user are first to submit a request to this ground station that controls the satellite. So the idea is to shortcut the ground station, use it for let me say, accumulating data, historical data, but the idea is to have, now you can do that actually. You can talk with your phone directly to a satellite with the latest technologies. So the idea is to reduce the amount of communication, so you do not need to send to the ground very high definition image that costs a lot of bandwidth, but the customer just would like to know if what he's looking for is there or not. So the information is simple, but to do that you need aboard of the satellite the capability to answer this question. So is there, in the defense case, is there the enemy or is the situation is clean? Provide the answer. This is the only things that you want to know. They do not want other things. Then we are also designing a cloud stack for our customer, but also for the national cloud for Italian public administration. And this is based on OpenStack, and the idea is to get rid of legacy hyperscaler or other software stack that require licenses. And I think we are going live with this system the 1st of January next year. So we are developing it. We are already using it for internal purpose. Also because not only the public administration, but also defense. And the defense side, we are talking much more, along with HPC, many board, we are talking of cloud solution for the defense. Why? Because we need to enable cognitive solution. You have to cross-correlate data among different domains in order to have what they call it information superiority. So if you're not able to cross-correlate the data, to share the data, and now today this data are in silos, and it's really difficult to cross-correlate, to have a solution that can cross-correlate the data between them. So we also provide a solution, and in fact, along with the let me say, the unit that provide consultancy services to allow customer to run HPC infrastructure. We have also a center of excellence with many data scientists that collaborate with the customer or with internal Leonardo division to essentially three main application area. So artificial intelligence, everything is artificial intelligence. But what we call also deep digital technology. So we explain to people that in order to run properly AI, they need to know that beyond the Python, whatever, there is libraries, parallel libraries, memory, CPU, GPUs, and the detail may do the difference in terms of efficiency of the and performance of the solution. Many AI experts, they do not nothing about HPC and the stack, and profiling for them is something weird. Why I have to profile my code? No, just let's see where the bottleneck is. You claim your code is slow. Let's see if it is a problem with the GPU, with the memory, with the disk. So why it is slow? So they have no, it's slow. I want it to go faster. Buy a new GPU. Let's see why it is slow. Maybe it's not a problem on the compute side. Somewhere. So these are so compiling, because when we move from x86 to ARM, so some customers say, okay, I want this new machine that is integrating a GPU with. You are aware that this is not x86, but it's ARM, and you have to recompile everything. What? No, it's a different architecture. You do not simply. So things for us maybe are obvious, but you have to think that for those that use the machine or these that have the need, these are less obvious things, because they have been told that they simply, or they are used in the workstation world to download a container from a container library, a Docker library, and play it. Say, look, this is, you have to be aware that this is, so you do not, maybe in x86 you have a full range of container, but you do not have it in the ARM architecture. So maybe something you have to recompile. So are you able to recompile a full stack also? Because when you see this AI stack, it's a deep tree. So you start with a very small Python library, find you recompiling the kernel, because everything is connected together. So this is another detail. And quantum computing. This is, we are exploring, especially we are, I think, very good team of experts that are able to write quantum codes. And we are concentrating our effort in writing new quantum solution, quantum codes, for when the quantum machine will be ready to be comparable in terms of reliability, performance, result with the HPC. And we see, obviously, quantum computing as an accelerator of the high-performance computing, not as a replacement of. And this is also tough to explain. People think, okay, shall we buy a quantum computer instead of this old crappy, very big quantum computing remote? No, quantum computer cannot do, if your target is doing parquet table, quantum computer cannot do parquet table. No, why? Parquet table is a big data application that requires a cloud. A quantum computer solves just one algorithm, if you're lucky, and you have to code it in quantum logic using Pauli matrix. That's all the difficulties you have with quantum computing. This is for artificial intelligence. The skill, I can go fast here. Obviously we have people that are able to deal with natural language processing and that are able to train their own model and clearly to build a solution. But with aerospace and defense, an important application still is computer vision. So one of my young colleague is very smart guy, is using artificial intelligence, is building application that from a picture can rebuild the 3D structure of an object, and from this derive the also the CAD of this object. No? So you can have a picture and reverse engineer the picture to be the 3D and the CAD of the 3D. And also for the navigation to use and build a situation and using different kind of cameras. You may have infrared, you may have, so sometimes you have to fly in a cloud, or you have to fly in the fog, especially helicopter. The problem is when they come close to the ground, you may find smoke, fog, but in a rescue mission or in a tough mission, you may have different conditions, and you want to save the vehicle and then the pilots and the crew, and so you need to navigate also using other sensors that can be on board of the helicopter. So there is a huge work we are doing in sensor fusion and try to build an alternative to what is visible. So rebuild the visible scene in a situation where the light is not propagating. Well, time series anomaly detection, this is important, you may understand in industry. We do a lot of reinforcement learning, graph neural network, and signal processing, sensor fusion, as I said. And clearly, among other things, we have also expert in trustworthiness, and because we would like, then Leonardo would like to sell solution. So there is two streams, one for the defense, one for the civil world. The requirements are different, but also the certification process are quite different. This is where we already have projects and customer. As I said, cross division, this is almost internal. Space division grow. Well, another problem we are facing in a company, in aerospace and defense company, and I think is a problem common to many European companies working in defense, is capacity boost. We obviously, for the geopolitical situation and for the investment, like NATO and Europe are requiring to the state, the number of orders we start to receive from the customer are growing, but we do not have yet the capacity to reply, to follow with the products, the backlog. So the backlog of order is increasing. So that one of the problems is how we can boost using AI technology, how we can boost the capacity, and most often is a process. The problem is in the process, which is slow, not just in the plant that build the real stuff. It's in the process. No. It's a slow process. There are a lot of papers, documents, and a liturgy of many things that we hope with AI we can sort out. So just one of the things we have great success with this kind of solution is, with the AI solution, is quality assurance. So in quality assurance, in aerospace, many times you find very silly things. So people going look at each square centimeter of the device, looking if it is okay. So the idea is to substitute this manual inspection with an automated inspection. The problem is that in the procedure, validated procedure with the customer, there is written manual inspection. So the customer pretend, have you done the manual inspection? So look, if you want manual inspection, you have 10 months longer lead time. If you allow me to move to a more automatic inspection, maybe your product will be ready in 3 months instead of 10. So these are and this is a procedural problem, it's not a technological problem. I will skip a little bit, so now we are promoting HPC at Italian but also in international level, mainly in this sector. Aerospace and defense is our main sector. Government is the second one, obviously. Leonardo is a public company, but the majority of stakes are owned by Italian government, Ministry of Finance in Italy. But we are talking also with the pharma company, so life science and healthcare. So public healthcare can be, they will need to run AI solution as well with the new tomography, with the new NMR, with the new, they will have an enormous amount of data. We are working on brain scanning. Just one project we have with the hospital is how we start to use AI to build a digital twin of the brain to monitor the evolution of illness, brain illness and pathology, in order to prevent and take measure. And the idea is that tomorrow they are going to buy, they call me an 11 Tesla NMR that is able to resolve the brain with the accuracy almost of a neuron. And so one scan is a petabyte or more of data, and what you can do with a petabyte, you cannot do explore it as they do so far. You need something automatic, and you need maybe to scan the patient every 6 months and look at the pathology, how it evolves. And this is where we are trying to apply HPC with healthcare. Energy and utilities. Here there is the problem related to the differentiating the source when you have solar panel, wind, and nuclear power. We just in Italy signed a joint venture with National Enel, which is a national energy company, and Ansaldo to build in Italy a small modular reactor business, where my unit will be in charge of designing explore what is possible to do in terms of AI and digital twin to manage a small modular reactor. Financial service, and last but not least, manufacturing. Let me go through and explain a little bit more what we do in the defense side. So one of the problems we are facing in the defense side is the so-called multi-domain approach. So multi-domain means that you would like to integrate the data from multiple domains, air, sea, land, space tomorrow, to get what is called information superiority. So the idea to have a complete awareness of the situation. So, and to do that, you have to integrate the data from all the domain, and all domain, the problem is that all the domain have maybe different rules, different standards, and since we are building devices for all the domains, first of all, our own devices. So we sold to customer have to agree to share a common base in order to build or to provide the capacity to build a multi-domain approach. And so we are discussing with all our colleagues, really producing airplane, helicopter, tanks, radar, satellites, in order to try to have a common ground also of competencies, such that everybody have a complete understanding of what HPC infrastructure, data lakes means, and not easy. And once again, one of the main obstacles are regulation and not technology, because you have maybe different regulation in different domain, and also sometimes the fear of losing power. So now, at least in Italy, the data collected from one of the army forces are of responsibility of the head of the army forces. This is written in the law. So in order to share with the other, and you can imagine at the European level, so it's already tough to integrate the data at the national level, and we are speaking of what we can do in order to so if Europe would like to have a sort of information superiority, we need to have a way to cross-correlate the data from many different forces, and so far this was one of the tasks of NATO, but we know that NATO is not enough any longer. So I think we need to have, I see the opportunity to go beyond the NATO and having something different, but this is not our task. We are technologists, and it's just an opinion. It's of someone else's task to take decision in order to make this happening, but the technology is there. We have proven that we can integrate the data from different sources. This is at the company level for our customer. We can provide the data and integrate them and allow the sharing and having a AI model that not too difficult from the point again of the technology, but in terms of integrating different domain expertise. Once again, this is something related to, once again, to breaking silos. So in order to have the possibility to what we call run advanced digital twin, because digital AI everything, and in this industry every piece of software is a digital twin. Okay. Yes, you have integrated so 30 years ago, every machine has its own monitoring stuff. Now you can collect all the monitoring stuff in one single software, but this is not a digital twin per se. And so we start to speak about advanced digital twin. So what we intend with advanced digital twin, we intend a software that integrates two streams, essentially. What is mostly known as digital twin in industry, which is data-driven, is essentially a data-driven digital twin. So you have machine in your plant that they produce stuff. They have a lot of sensors. You collect this sensor, you put them in a big data ecosystem. You analyze this data with a cloud stack that you need HPC in the cloud, because you have to run, we internally to the company use, in our HPC every night, we run 100 Spark job that analyze all the data and produce new output for, let's say, being able to provide a report to the manager of the factory or to the manager of the fleet of helicopter. This goes also to the customer. So the manager of the fleets of the helicopter can see how his helicopters has flown the day before. So if the pilots have done the right maneuver, if they have wasted fewer because they have taken some detour, I don't know. So they can check and see all this using this data-driven digital twin. But we add to this a model-driven digital twin. So we use high fidelity simulation in order to have a model of in this case of the helicopter, in order to provide information that are not there in the helicopter itself, like virtual sensors. So through the simulation, through AI model, we can provide, even if we do not have data of the engine, we can infer, having used a model for the engine of the helicopter, we can on the basis of the performance, we can infer some data about the engine, even if we do not have the data for this particular helicopter. So we call it virtual sensor, and this goes through a very high accuracy simulation and a model using HPC. This can allow to make prediction and change, and we use it in 3 different situations. Let me see. Design, we use the same cycle also for designing a new plane or a new helicopter, in building and in operating so the digital twin should adapt to the 3 different, so the digital twin at the end is a bundle of software, is a solution, okay, with different view. There is the customer that sees something and the engineer sees something else. It is a complete solution that can be used in different, just to make you, this is something of an application of the advanced digital twin. So we use HPC in all these phases. So we do high fidelity simulation. We need also this high fidelity simulation because when one of the business of Leonardo is training, these is a training center for pilots, and we would like to have real scenario simulation. So the training was in the past based on a predefined route, so the pilot has to fly in a particular predefined situation. We would like to have open world situation where the instructor can decide on the fly what kind of a maneuver to train to ask for the training, and also we need to have this full. I don't know if I have a video. Hopefully, this is a real video. This is the same plane we build. This is a Boeing. From Boeing, we have the license to build one identical one. And this is what happens if you do not take into consideration all the proper, because this is a complex object. You have 2 rotors, and you have to respond to different pressure, and the landing on an air carrier is a very it's a problem for this kind of. It's an hybrid between we can call it a rotorcraft. It's an hybrid between an airplane and. You can see it in a lot of movies. So this is the Osprey, and we run the similar simulation for our Navy because we build a similar airplane, and we would like to sell it to the Italian Navy, and this is an Italian air carrier, so we run the full-scale simulation of the air carrier with the landing of this guy in order to simulate, and then we build the simulation, we build the ensemble of the simulation in order to find enough confidence that a maneuver is safe. And then we replicate the maneuver on a real air carrier with the real airplane, and thanks God, the land was safe, and we were able to demonstrate that using this high fidelity simulation in a complex scenario, and obviously you cannot run high fidelity simulation at the full scale. You need AI to interpolate somehow the different snapshot if you want. Time is up, okay. On quantum, well, these are real applications we are writing. Solve the problem of covering a land with where you have some disaster and the mobile phone connection have been disrupted, and you can go with drones and recover and build the possibility to have mobile connection, so with 5G. And there is an optimal, so the problem is how many drones, where I have to put the drones. And the same with the wildfire monitoring system. We have a huge problem in the south of Europe with wildfire, and the idea is to use pole and drones to move camera where you have the higher probability to see a wildfire. But we use it for, obviously, we test quantum in order to crack cryptography. We also have a project to do CFD with quantum computer, very interesting one. We are happy with the result. We are clearly very small scale, but we are able to recover small, interesting result from the CFD. And the monitoring, once again, to use, I conclude that, well, AP use case. So this one, it was quantum, but the same. When in AP, we since the beginning, we start to propose a sort of breaking the silos since the beginning. So in AP, we break the silos since the beginning because we propose to use HPC along with an edge application. Leonardo is selling this solution to different governments and also in Europe. And the problem is when you have a lot of cameras, now we can use AI in order to not operator, real operator, in order to integrate. And the problem is that you have different algorithms that have to run in the camera. So you have identified people on the ground. If there is some sound of a shot, if you have a crash, if you have a crowd. So you have different AI algorithms that have to run in parallel in order to monitor a situation. This is the stack we are working in within API, and we claim that this is the HPC as well. Not only the big science, but we use, in this use case, all our full capacity of competence in HPC in order to optimize, to port, and to. I would like also to say that we are also in RISC-V project. So the main three projects are Isolde and Tristan, which are from the ChipJU, and DER, which is our HPC project. In Tristan, we target industrial robotics and manned drone. Remember again, since the beginning, while we are breaking the silos internally, so or even in project, we are participating, trying to port HPC. And in Isolde is instead to use RISC-V to have computational capacity in space, and that's it. Thank you.